Hello guys, it's Paul and welcome to another episode of Paul Plays Shenzhen I. So this episode we're going to be doing this new puzzle, Harmonic Maximization Engine. Now this puzzle links to the printable manual, which is a PDF. So there's a nice sort of mocked up page from the client telling you what he wants. We'll get to that in a second. So we're going to do a new design and open it. So what we have here is we want you to design this audio harmonic maximization engine. So audio in is a simple input connected to an audio source. Audio out is what we need to harmonically maximize, and this maximize is a button that you press. So when you press the button you get your maximal audio output, and without it pressed we just want the bare input. So if you see this here, if we look down at the bottom of the screen, the verification bit, this line and this line here are identical until this happens. The button goes high for this part of it here, in which case we harmonically maximize the audio output, then it drops again, and so on. Now it's quite a simple formula. I think I have the PDF in the background. You won't be able to see it because of the way OBS is capturing the video. I don't think you'll be able to see it, so just trust me. There's a nice sort of page mocked up in the PDF with the client spec. So it's basically subtract 50, multiply by 4, and add 50. It is really that simple for this step here. Now, immediately the first problem that we have is that there are 3 of these buttons, or not three of these pins, 2 inputs and 1 output, but none of these devices have 3 of these P pins. When they get bigger, they get more of these X bus pins. So that's the first problem to solve. So what we need to do is, if we were to connect P1 to the output, an audio in, and let's just do it basically, move P0 to P1 and sleep for 1. We're good here, but obviously when the button is pressed and we need to maximize, we do nothing. We're still copying over the audio input to the audio output, so it's kind of half right. So what I'm proposing to do is use another one of these and somehow convert the button press into an X bus. So if we said every cycle we're actually going to take the value, so basically I'm going to move P0 to the accumulator and then move accumulator to X1. So it blocks straight away. And sleep for 1. Possibly, I'm not sure if I need that. We'll see again. I'm not 100% sure from reading the manual how the blocking actually works. We'll find out. So what I'm trying to do here is send, instead of like it being a value on a pin, you're almost saying, right, I'd like to send, say this has got whatever it has, and it comes in for 54. You read a pin, you see 54. This is almost sending, the number 54 is kind of a data packet on their pretend bus to here. So actually that is incorrect. We know it's not this number here we're sending on the bus. It is gonna be just 0 or 100. And we know we're gonna get one of these every cycle. So move X0 to... Oh, I wonder, can we just test equal x0 and 100. Have we got 100 sent to us on the bus? If it's 100, we are maximizing. So we need to move what I'm looking to do, move P0 to the accumulator. We'll do that all the time. And move accumulator to P1. Now, does that still run in terms of the blocking logic? It's still not going to do this harmonic modulation stuff. But yes, so it's pumping this data over. We're just testing if it's equal to 0. So the blocking, both of these are running fine. So we've converted this, we've made it more complicated, we've achieved nothing else. But in theory, it's now set up. Because if, say, it was equal to 100, I want to subtract, I believe, I could just check it, I won't check it just in case I've remembered it. I read this page, subtract 50 from it, multiply by 4, and add 50 again. So again, this is the we've done a test up here. So this is set a flag, either true or false, where the last test was true or false. So and the test we did was, did we get 100 down, which is the value here from the, if the button's pressed and we want a harmonically maximized output. So these 3 lines here only get run if this test happens. So normally, let's say the button isn't pressed, we do the test, it gets a false, we grab the value from the input, we got a false, so that doesn't run, that doesn't run, that doesn't run, so we just move the output straight across, and we saw that working the last time. Hopefully this time, when the button is pressed, that'll now have a true, like the last test was true, so we're going to run, and hopefully we should get the harmonic output as well, and it is looking good. So that's the first 4 we're doing. It's and then we speed up and we do. Yes. So we're a little high on power usage, but again, I'm just trying to solve this. So I'm gonna stop even pretending. Right, now the only other thing I was gonna do for the end of this puzzle is, as I was having a look at the manual, there is this thing. Now this thing, I believe, the DX300 does what? Let me just read the manual for this for a second. Sorry about this, guys. I'm looking for the DX. Manual is very interesting. It's lovely. No, that's not a word, is it? It's very nicely done. The read-only memory. It's called the DX300 is a digital I/O expander. And what it does is it write a digit, read from any X plus pin to get a 3-digit number that captures the state of the simple I/O pins. And basically what it's going to do is it's going to pack the value of the pins into a 3-digit number with 1 or 0 in each of the digits, depending on whether it's on or off. And it says here the value in the ones is P0, the value in the tens column is P1, and the hundreds column is P2. So if that makes any sense, what I'm going to do is I'm just going to throw that away. This on instead. But it's a pin type mismatch because it should be the other way around. like that. So my theory is this pin, it only works like using these pins as they're fully on, fully off, 0 or 100. But if P1, and we said it was in the 10s. So my understanding is, and we know these two are 0, so we don't need to do any clever ANDing or anything to get rid of them. So what we can do here is this number coming out of this should be 0, 0, 0 if there's nothing on P1, or 0, 1, 0. The 10 digit is used to store the state of this input pin, and we'll set it to 1. So my understanding is if we run this now, it won't work. It'll get this wrong here. But if I change that now, obviously I'll just do 0, 1, 0 just to make it clear, although technically that's 10. I run that, yes, it's working again. So we've used this new part, this DX300. So what it does is it treats these 3 input pins as either 0s or 1s, whether they're 0 or 100. It makes a new digit, packing those 3 together. This one into the 10s, I think this one into the 100s, and that one into the 1s, and fires them off down here. So, dramatically dropping the power usage and our production cost. We could be making cheap electronics for a living. Right guys, hope you enjoyed that. I don't think I'm going to do anything more with it. We just had a look at starting to use these DX buses a bit, had to play with this new components, the DX300. But we've also seen how, pretty much what this was doing with explicit code, this does by just being that component, which is nice. I just think it'd be lovely to have a game where you could sort of almost build your own components and repackage them, but I presume that's not part of how they see this. You're always using these predefined things we have here online. Right, okay, thank you for watching. I hope you enjoyed it. If you did, you could drop a like on it. If you like what you see on the channel, please do consider subscribing. Nothing else really to say. Thanks for watching. Bye now.